Today we're going to look at some special angle relationships, okay? Some special relationships that kind of show up that we can kind of use, all right? So the first thing we're going to do is kind of cover what we kind of looked at in the warm-up there, what I call that angle addition postulate, okay? So we'll start with that one since we didn't get to that. It's a very basic angle addition postulate. So it's just like the segment addition postulate, except it's a little bit harder to guess visualize or something like that. Okay. And here's basically how it's. Here's one way to state it. If point A, so I'm going to put a little point. If point A is in the interior of angle COP. Okay? If angle A is in this, if point A is interior of angle COP, thank you, sir. Okay? Then angle COA plus angle AOP equals angle COP. All right, you might look at that and say, that is a lot of words, and I'm not really sure what's happening. But let me show you the picture then, too. We'll show you a picture that goes along with it. Okay. Because, again, it's important for us to be able to read the math and then be able to interpret, what's kind of like happening here. And math statements are very dense sometimes. Lots of things going on. Okay. So let's again kind of break down what we're talking about here. So we start out with if point A is in the interior of angle COP. So it looks like we're going to need to start by drawing an angle COP. So I'll draw an angle here. Okay, something like this maybe. All right. Now this angle needs to be named COP. So can I'll have to use 3 points here to name this angle. Okay. And can I put these letters anywhere I want on these 3 points here to name the angle COP? Okay, no. Okay, so someone raise their hand and tell me what point has to go where. So yeah, let's go there, Antoinette.
Point O has to go on the vertex. Yes,
point O has to go on the vertex. Remember, guys, when it's 3-letter name for an angle, that middle letter always is the vertex. So this point has to be O. The pointy part of the angle has to be O. And then Antoinette, what about the other 2 points? Okay. Although, in this case, you could also flip those around too. So it doesn't matter. You could put the C here and the P here, or the P here and the C here. That doesn't matter at this point. Okay. So, but the middle letter does have to be O. Okay. Sorry, the vertex has to be O because the middle letter is O. That's always the vertex. All right, great. So we have an angle COP, but then we have point A is in the interior of angle COP. Now we haven't talked about being in the interior of an angle, but I think most of you guys probably know what that means, right? What does it mean to be in the interior of something? Inside it, right? So what do you think that means here? When we're looking at this angle, what does it mean to be inside the angle?
Near the vertex.
Yeah, yes, in between the 2 rays, right? So this would be like outside or in the exterior, right, of the angle. This is right in the interior. So A can be like right there if we want to put it, okay? And so then by putting point A in the interior like that, and I can then like kind of create another ray here, okay, through that. Okay. And so we started with a big angle, COP, angle COP, right, angle COP. But then with that point A, we now created 2 smaller angles, right, angle COA, and then angle AOP. And how should they relate to angle COP? Well, it would make sense here that angle COA and AOP should add up to make angle COP, right? So we can also use some numbers here if you think that might help you. So we can put like an angle 1 here, an angle 2 here, and we can call this big angle right here angle 3. All right. And so what this basically just means is that angle 1 plus angle 2 has to equal angle 3 if you want to use the numbers instead of having to look at those 3 letters. All right. All right. So that's the idea. You can add together angles, and they can, then give you, help you to solve problems with angles and things like that. All right. So we're going to look at an example of that here. So let's see. Again, something that we kind of saw in the warm-up, maybe. Okay. So let's. So we'll do an example here. Find the value of x. Okay. Given the measure of angle PQS is equal to 112 degrees. And we'll do 2 of these here. Okay, we'll do 2. All right, so we're going to find the value of x given that the measure of angle PQS is 112 degrees. All right. So I'll just draw a little picture here. All right, we'll draw angle P, Q, and S. All right, and we want to find the value of x. So let's say that, excuse me, we're going to draw in some additional here, because we don't have enough information here. We don't have anything with x in it right now. So let's go ahead and draw a picture here. All right, and let's call this R. And we'll say that this angle right here is x degrees. And this angle right here is, we'll say, 56 degrees. So there's our setup. If you feel like you can already do it, feel free to go ahead and jump ahead and get started on it there, and I'll call on someone here and see what we can do. So, all right, Addie. So, how can we set up, or what can we do here to solve for x in this problem? So let's take a look at here at how these things should all be related, right? So we have this piece of information right here. The measure of angle PQS is 112 degrees. So PQS, that's the big angle, right, is 112 degrees. Uh-huh. So you want to show that this big angle right here is 112 degrees. Okay. And then what can we do to help solve for x? You can set up an equation if you want to, or you can just tell me also like what we could do. Okay, you don't have to worry about setting up an equation if you don't want to. So if the whole thing is 112, this piece is 56, and we want to find the other piece, the other angle, what can we do? Yeah, exactly right. 112 minus 56 degrees there has to give us what's left over, the other angle. Because remember, these two angles, the 56 plus the x, have to add up to make this big angle 112. And so, yeah, you just do 112 degrees minus 56 degrees, and that gives us, what is it, 56? Weird, okay. 56 degrees. So it just happened to work out as the same number there, all right? So, well, that's interesting then. So if this angle is 56 degrees and this angle is 56 degrees, what could we call this ray RQ, or QR, I should say? What's this ray QR called? An angle what? Bisector, right? It's cutting the big angle, 112 degrees, into two smaller but equal angles. So it just turned out in this case that QR is an angle bisector, but that's the idea. Okay, the equation. Anyone have an idea? What's the equation that we could set up here? Yeah, Robert, you want to go for it?
X plus 56 equals 112.
Exactly right. the smaller angle plus the other smaller angle has to equal the big angle that, together. So, and then again, the same thing, Addie, you can see it'd be the same step that you just did. We would then subtract 56 from both sides to end up with the 56 degrees there. So that's another way to do it too, okay? So I'll just show that right there. Two options there, okay? These angles are a little bit harder to see sometimes for us, so that's why we're doing these. All right, let's try another one here. All right, we're going to use the same directions, so I'll just kind of like do a little squiggly line, and I'll just put it over here to the side. So we're going to use the same directions. We want to use the fact that the measure of angle PQS is 112 degrees. I'm going to change things up just a little bit, how they look, so that way it doesn't look like the exact same problem. All right. Draw something like that. And so we'll say that this is P, the vertex is Q, and S is over here, and then the other point, again, we'll call this R right in there. Okay, so again, it's the same directions. We still want to find the value of X given the measure of angle PQS. So that was like kind of like one example here, and we'll do another one right here. So 1 and 2, we'll number those maybe. Okay. So there's our picture. And I'll label some things here. So let's say that this angle right here is 72 degrees now. All right, so that's RQP, or PQR, however you want to say it there. And let's say that this angle right here is 10x degrees. Okay, big angle right there is 10x degrees. Okay. All right, so let's see here. So again, the idea is that this little angle, right, is 10x. This angle is 72, and then PQS, which is the big angle, is 112. Right. So, Courtney, any ideas here? What should we start out, or how should we start this thing out?
I was going to do
112 is the big angle here. So I'm going to go ahead and I'm going to label that in kind of thing. So from here all the way around, right, that's 112 degrees, the big angle. Okay.
Plus 10x equals 72.
Okay, so be careful here. If you look at this, the big angle is 112 degrees. So what we do want to add two things together here, but what two things do we want to add together?
The 10x plus the 112.
So 10x, we're going to add together, but again, be careful. The 10x is the small angle. What's the other smaller angle here? 112 is the big angle. It's the entire thing. Yes, exactly right. It's going to be the 10x, the small angle here, plus the other small angle together with it, make this then big angle SQP. Do you see that now?
Yeah.
Small angle here plus this small angle together make the big angle. Okay? So that equals 112 degrees. And that's 10. And that's 10. Question? I'm just stretching. Okay. Oh, you got the answer?
Oh, yeah. Well, I was going to say it when X equals 4.
So let's see. So how can we get X then at this point? What should be our next step? Now that we have this equation set up, what should be our next step here, Alex?
I just tried to figure. Well, I just did try to find out how much you need to get to on YouTube.
Oh, so you kind of did you guess and check a little bit, or?
Well, kind of, yeah.
Okay, that's fine. That works. Okay, let's go. I'm gonna just finish solving the equation here. Let's go to Kwanya. I haven't heard from you yet. Okay.
So I should subtract 72.
Subtract 72 from both sides. You got it. Okay, and so that leaves us with 10x here, and then 112 minus 72 is 40. Okay, good. And then what? Divide by 10. We get that x is 4. Okay? All right. So we found the value of x. Now, we've answered the question, right? The question just said, or the direction said, find the value of x. So we did. Now, Courtney, I know that x is 4. I know that this angle, though, is not just x, it's 10x. So if I wanted to find the measure of this angle, what should I do with this number 4 here? If x is 4, what can I do with this x right here?
Take 10 and times 4.
Yeah! And what's 10 times 4? 40. So this angle here is also 40 degrees. Sometimes you'll also be asked, Courtney, what the actual angle is. Once you solve for x, they'll say, okay, and then find the angle too. So that's what you just did right there. So very good. Okay, so 40 degrees is the answer. All right, wonderful. Thank you. Okay, cool. Okay, so let's keep moving here then. So that's the angle addition postulate. All right, now we're going to look at some other kind of important angle relationships that we should be familiar with, okay? So, kind of scoot on from there. All right, the first angle relationship, there's kind of like two that kind of go together here. We're going to talk about complementary angles. All right, and this is different than the word compliment, where it's like, Ma, you look very nice today. Okay, that's a different kind of compliment, spelled differently, right? When you say something nice to someone and compliment them, that's C-O-M-P-L-I-M-E-N-T. All right, when you put the E there like that, it's a different kind of word. It means something different. All right? So complementary, right, are two angles, all right, that add to make 90 degrees, okay? Which, if two angles add to make a 90-degree angle, what's another word we have for a 90-degree angle? Right angle, a right angle. Yeah, no, that's okay. Yeah, less than 90 degrees would be what you were saying there, Courtney, right? Or a right angle. Okay, so if two angles add to make 90 degrees, they are a right angle. The two angles do not have to be next to each other, okay? They could be like two separate angles. But they add to make 90 degrees, and they're complementary. All right, so let's just do an example with that. So let's say that angle 1 and angle 2, for our examples here, are going to be our complementary. All right. Find the missing measure. Okay, so those are our directions. Angle 1 and angle 2 are complementary, so we're told that they're complementary, means they add up to 90 degrees. We want to find a missing measure, so I guess there's going to be something missing here in the picture. So let's go ahead, I'll just draw some here. So, all right, so I'll draw one angle there, I'll call this angle 1. And I'll call this angle 2. All right. So, again, kind of reading through here, angle 1 and angle 2 are complementary. We just heard that complementary means they add to make 90 degrees. We want to find the missing measure. So here we're told that angle 1 is 62 degrees, and we want to find angle 2. Remember, they're both complementary. So, Melissa, any idea here? What can we do to figure out what angle 2 has to be? Yeah, 1 and 2 are complementary. That means they add up to make 90 degrees. If we already know one of them, how can we find the other one? Yeah, exactly right. 90 minus 62 equals 28. Very good. Okay, so 28 degrees is our answer there. Alternatively, if you wanted to write an equation here, you could say, like x, the unknown angle 2, plus 62 equals 90, and then solve it that way too. But also just subtracting is fine. So 28 degrees there. That's it. Very good, Melissa. All right. How about you guys try one here real quick then? I'll give you one. So you guys try this one, and let's see. I'm going to go like... All right, so I'll say this is angle 1, and then... This is angle 2. And I'll say that the measure of angle 1, that's what we're trying to find. And then the measure of angle 2, that'll be 71 degrees. Okay? So go ahead and find the measure of angle 1 there, given the fact that they're 1 and 2 are complementary. Alright, so I'll kind of come around and help. Get stuck on something. Or if you think you got the answer, I'll come around and check it too. Real quick. Okay, good. Yep, good job. Well done. Okay. Like you go. Yes, good job.
Oh, got it.
No, yeah, I see what you're saying, and that, I mean, that's like totally legit what you did. You know, my concern is that sometimes you may like not be able to guess it, you know what I mean? So also, so that what you did is fine, but also understand, you know, setting up the equations can be helpful too. If you get stuck, you need to like, if you're unable to figure out what the answer is off the top of your head. That would give you this angle, but you then have to divide it by 10. That would give you 40 degrees, and then you divide by 10 to get it back. So I mean, you know, you're right. I mean, that's ridiculous. Yes. Yeah. If you wanted to. Yep, exactly right. Got it. Yeah, good job. Awesome. All right, so here we go. Let's take a look here. Let's go to some we haven't heard from yet. So Ray, you come up with an answer here for this one, the blank. 21? Close, okay, so you're very close there. So what can we do here? Again, these two things, yes, subtract, right? So it'd be 90 minus 71, and that's 19 degrees. And you told me you needed to get a calculator sheet, and I have one for you too, so I'll get you one. But you had the right idea, so exactly right, all right? 19 degrees is your answer there, okay, 19 degrees. And here, if you want to borrow that for today, you can borrow that too. I have an extra. Okay, good job. So now, let's keep moving then. All right, so in addition to actually I want to do one more complementary one. Never mind, I apologize. I have one more. We'll do this one together though. All right, so the last example we'll do with complementary angles is we're going to find x given, okay, that angle 1 and angle 2 are complementary. So we'll do one more here, but we're now going to do one involving some algebra. Okay. Now we're going to do one here involving some algebra. Okay, so I'll draw one more picture. Okay. By the way, guys, if you're not given a picture in geometry, sometimes it's helpful to draw the picture, right? In this case, I'm giving us a picture, but sometimes we're not given a picture. But it'd be helpful to draw one sometimes. All right, so angle 1 and angle 2, I'm making them complementary. I'm also putting them right next to each other in this case, right? They both have the same vertex. When they're next to each other like that, we call that adjacent. Adjacent. Okay. They're next to each other. All right, and let me give you guys some measures here. Let's say that the measure of angle 1 is 3x minus 10, okay, degrees. And also the measure of angle 2 is 2x plus 20, again, degrees. All right, so now we're throwing in some algebra. So hopefully some of you folks that like algebra, all 2 of you maybe, I don't know how many people like algebra. We'll find out as we go, kind of thing, who likes algebra more and who doesn't. All right. All right. So these 2 angles here are complementary. That means they have to add up to 90 degrees. So Eric, any idea here about how we could set up an equation with these quantities here? What's the kind of equation we could set up?
3x minus 10 equals 2x plus 20, but I don't think it's...
Okay, yeah, do these 2 angles have to be equal to each other?
No.
No, but they are complementary, which means what's true about them? They have to what? Add up to make 90. So I shouldn't say 3x minus 10 equals 2x plus 20. I said say 3x minus 10, if they have to add up, plus, and then what? 2x plus 20. Now for an equation, I need to have it equal to something. That has to equal what? 90. There it is. That's the idea. Yes, they look equal, so you got to be careful about that, right? Sometimes if they look equal, you might say, oh, maybe they're equal. Well, we're not quite given enough information there to say if they have to be equal. But certainly we know they must add up to make 90 degrees. So 3x minus 10 plus 2x plus 20 equals 90. All right, so Eric, do you want to continue solving here? Yeah, go for it. Okay, what should be our next step here? We have a bunch of x's, so how can we start solving this? What should we do? So 3x plus 2x is 5x. Very good. And then we took care of those. Are there any other like terms to combine over here?
10 points.
Yeah, we have a minus 10 and a plus 20, so that makes, when you put minus 10 with a plus 20, that makes plus 10 equals 90. And exactly right. Now we can start solving the equation. Once we've simplified it some, we get 5x equals 80. And then last step. Oh, divided by 5. Yeah, no, that's okay. I'm not going to like put you on the spot here if you don't. It's 16. It'll be 16. Yep, that's fine. Don't worry about it. Okay, you guys will be able to have calculators and stuff like that. So, you know, I mean, I appreciate the effort though. That's good. I like the little mental exercise, but also don't fret. You will have calculators, so I'm not going to like, you know, make you figure out, you know, what 122 divided by 11 is. You know, sometimes it won't work out nice. So, but anyway, x is 16. So we're done here. We're done here, right? We've gotten the x value. We've answered the question. All right. We could, though, go one more step here, right, and find the measure of angle 1 and the measure of angle 2 if we wanted to, right? So, Eric, if I wanted to actually figure out what angle 1's actual measure is the measure of it 16? No. What would I need to do to get the actual measure for angle 1?
Put 16 for x.
Yeah, put 16 in for x. So it would be 3 times 16, which is 48, minus 10, so it would be 38 degrees. Okay. And then 16 plugged in for to find measure of angle 2, it would be 2 times 16, 32, plus 20, so 52. Okay. And then, this might not blow your minds, but, I mean, 38 plus 52, what should that equal? Better equal 90. And there it does, right? Okay, there it does. They're complementary, so those two angles better out to make 90 degrees, and they sure do. Okay? So alternatively there, once you figure out angle 1, you could have just subtracted that from 90 and gotten the 52. All right, that was complementary angles. We also have supplementary angles too. We're not going to do as much as we did with that just because I feel like we kind of got the idea, and it's very similar, okay? So complementary angles, two angles that add up to 90 degrees. Anyone want to take a guess at what supplementary angles add up to, Eli? 180, you got it. That's exactly right, okay? Supplementary angles are two angles that add to make 180 degrees. Okay? Another word for a 180 degree angle is a what kind of angle? Straight. Okay, a straight angle. All right. Now, you might think to yourself, Mr. Widmeyer, all right, you just told me complementary is 90 degrees and supplementary is 180 degrees, but how am I supposed to remember those? I'm going to get those two mixed up. And yes, students do often get those mixed up. Here's how I'm going to tell you how I remember them, or how I remember them when I first learned them, okay? Complementary, 90 degrees, right? Supplementary, 180 degrees. So complementary comes first alphabetically, right? C comes first alphabetically, and the number 90 comes first numerically, right, before 180 degrees. So complementary, 90 degrees, and then supplementary is second alphabetically, and 180 is second numerically, right, in number lines. So that's how I would remember it. Complementary comes first, 90 degrees comes first. Supplementary comes second, 180 degrees is second then. And so that's how I kept those lined up. If that helps, I hope it helps. Okay? But there's how you can remember that. Or that's how I remember it at least. All right, let's do one example here. We'll just do a quick one because, again, like I said, I feel like y'all have the gist down with complementary, and it's just changing 90 degree to 180 degree when there's supplementary. All right, so we'll just do one example here with this. So angle 3 and angle 4 are supplementary. Find the missing angle. In fact, you know what? I'm not even going to do this one with you. I'm going to have you guys just try this because I bet you can do it. No problem. If you do have problems, I'll come around and help. All right? Well, let's say the measure of angle 3 is 157 degrees, and I want you to find the measure of angle 4. All right, so I'm not even going to show you how to do this. I think you all can do it. No problem, because it's just like what we were just doing. Okay, I think you can find it, no problem. I'm going to come around and help, though, if anyone needs help. But go ahead and just take 30 seconds. See what you can do there. Just take 30 seconds there. Awesome. Good morning. Yep. Are you still thinking? Nice. Good job, Ray. Yes. Good job. Nicely done. You got it. Good job. Yep. Excellent. See, okay. I knew it. Great job. All right. You guys got it. Yep. So the answer here is what? 23. You got it, okay? So 23 degrees. All right? So that's the idea. I could throw another one at you like this. We're not going to do that, but I mean just algebra kind of ones, right? Again, just if it's supplementary, you would just take these two things and make them add up to 180. You know, this plus this equals 180, not 90. So, all right. We'll continue on then. All right, other angle relationships. So another angle relationship is called a linear pair. Okay, linear pair. Now this one's nice because I feel like the word itself kind of gives away what the relationship between the two angles will be. Okay, so we all know pair means two, and linear, well, what does that mean? A line. So it's two angles that make a straight line. Okay, that's it. So two, now here's the one thing that's not indicating there. It's two adjacent. Okay, and again, the word adjacent just means next to. Okay, next to. All right. So, for example, I was looking at apartments recently, right? And so some places, when they're advertising for the apartments, they would say, like, the laundry facilities are in an adjacent building. So that means if I wanted to go wash my clothes, I wouldn't be able to wash them in my building. I'd have to go to a building next to my building to be able to wash them. That's what adjacent means, okay? Adjacent means next to. Two adjacent, and they're also then supplementary as well, right? Because if two angles add to make a straight line, that's a 180-degree angle. All right, so two adjacent supplementary angles. All right, I'll draw a picture of that here. I'm going to use a straight edge to kind of help myself. Okay, two adjacent supplementary angles. So there's like a straight line. And I'll label these things here. All right. So, someone want to raise their hand and name the two angles in this picture that make a linear pair. Someone want to name? Go ahead. Okay, so Gabe said ADB, angle ADB, and angle BDC, okay, are a linear pair, and he's right. Okay, so, you know, ADB, that's this angle right there, that's ADB. And then BDC, that's this angle right here. Okay, you can see, yes, of course, they're adjacent, they're next to each other, right? They share a vertex, and they share this same side, okay? ADB and BDC, they make a straight line there, 180 degrees. Okay. So let's see an example with this one. Let's try an example here. All right, so let's say that in this picture here, all right, that angle 1 and angle 2, okay, are the names for my angles there. I'm not going to put any letters or anything like that. We'll just call angle 1 and angle 2. I'll say that angle 1 is equal to 5x, okay, degrees, if you want to say that, degrees. And I'll say that angle 2 is equal to 3x plus 8. All right, so we'll say angle 1 is equal to 5x degrees, angle 2 is equal to 3x plus 8, and we'll say that angle 1 and angle 2 are a linear pair. Okay, angle 1 and angle 2 are a linear pair. And we want to solve for x. Okay. So angle 1 and angle 2 are a linear pair. That means they are adjacent. They're next to each other. Well, let's say, yeah, we can see in the picture they're next to each other, so that's not, anything that's like mind-blowing here. That means also they're supplementary, though, which means if angle 1 and angle 2 are supplementary, that means they have to add up to make what? 180. So, let's see here. All right, so column S, what's the equation that we can set up here if these two angles are a linear pair? That means they're supplementary. So they have to add up to make 180. So what's the equation we can set up there? What plus what has to equal 180? Well, these two angles. These two angles are supplementary. So it should be 5x plus what? 3x plus 8 equals 180. It's the two angles. Okay, it's these two angles that add up to make 180. Do you see that now? Do you see what we're doing here? We're taking the small angle plus the small angle, and it makes this 180-degree angle. Okay? Can you solve the equation from here, Colin? What should be our next step? We have some like terms over here, don't we? What are the like terms we can combine? Okay, so 5 plus 3 is? 5 plus 3 is what? When we combine, what is 5x plus 3x? Yeah, 8x. You got it. Good. Plus 8 equals 180. Okay, what's be our next step here, Colin? To continue solving, what should be my next step? Yeah, you got it. Subtract 8 from both sides, right? Good. I get 8x equals 172. And then what? Divide both sides by 8. You got it. Okay. Now, did anyone get this far? What do we end up with? Yeah, Robert? 21.5. Okay, so we got a decimal. Sometimes that makes us uncomfortable, right? And I'll be honest with you, very often, I mean, it's not going to be, it won't be very often that you get a decimal answer, okay? So I understand that, but in this case we do end up with a decimal answer. We did do it right, so it's 21.5. Okay, good job, Colin. Thank you, sir. And Robert, thanks for your help too. All right. So that's linear pairs. You can see the work is very similar to supplementary. Okay, very similar to supplementary. Okay. Whew. Almost. We're getting there. All right. All right. The next angle relationship we're going to look at is vertical angles. Vertical angles. Okay. So we talked about complementary angles, two angles that add up to 90 degrees. We talked about supplementary angles, two angles that add up to 180 degrees. We talked about linear pair, two adjacent, next to, angles that add up to 180 degrees or supplementary. Okay, now we're talking about vertical angles. All right, vertical angles are two angles, okay, whose sides are opposite rays. Okay. All these angle relationships will be on your quiz tomorrow, but you get to use these exact notes that you're writing right here to help you, okay? Eventually, we want to become very familiar with these so that we won't have to use notes and stuff to look at. But tomorrow you will get to use these. Okay. So I'm going to draw a picture here to kind of illustrate this. Okay. And I'm just going to number the angles, just because I think it's going to make things a little bit easier. Okay, so when I draw those two intersecting lines, I created 4 angles there, right? 1, 2, 3, and 4. Okay, 1, 2, 3, and 4. When I drew those intersecting lines, I created those 4 angles. Okay. So, in this picture, we have at least one pair of vertical angles. All right, so one pair of vertical angles here. We need two angles whose sides are opposite rays. So, for example, if I look at angle 1 is made up of this side of the angle and then this side. Okay. Now, this ray, this side of angle 1, has an opposite ray going this direction, right? That's the opposite ray to it. And then the other side of angle 1 has a different opposite ray. It's got this opposite ray. So, which angle is made up from the opposite rays from angle 1? Angle 3. That's right. Angle 1 and angle 3, okay, are vertical angles. Angle 1 and angle 3 are vertical angles. And there's actually another pair of vertical angles here. Can someone name the other pair? Eli? You got it. Eli's exactly right. Okay, and Eli was not thrown off, and that's good. Eli was not thrown off by the word vertical, right? Because vertical we think, oh, it's up and down. 1 and 3 are kind of like up and down from each other, right? So it's like that's the only pair of vertical angles. Well, no, in this case also 2 and 4 are going to be vertical angles as well. They are also called vertical angles. All right. Now, can anyone want to take a guess, educated guess, make a conjecture, we'll say maybe, okay, or a hypothesis. Anyone want to guess what the relationship between angle 1 and angle 3 are? Or the relationship between angle 2 and angle 4? How are those angles going to be related? What do you think, Debbie? Okay, they do share the same vertex. Yep. What about their measures? How will their measures compare? Like if I were to measure angle 2 and measure angle 4, how do you think they should compare, Alex?
I think they have the same measurement.
Exactly right. They are going to be equal. Yes. So in general, vertical angles, always I should say, in our geometry, vertical angles are congruent. They are equal to each other. Okay, so you can use that to your advantage here. Vertical angles are congruent. All right, we'll do one example here, and then we'll look at some more angle relationships. Almost done, though. Okay, so let me draw a picture. All right, draw a picture here. You guys are doing a great job here. Great, great, great job. Okay, so here's an example. And again, our directions will be to solve for x. Okay. Alright, so there's our picture. And again, we want to solve for x. So again, it's kind of nice because we're doing this problem in the vertical angle section, right? So that there's probably some vertical angles here, but let's just check to make sure. So Thomas, are there vertical angles in this? Are these two angles are we considering these vertical angles in the picture? Absolutely. So then, how should these two angles be related to each other? They should be what? If they're vertical, that means they are what? Equal. So to set up this equation, I can write 5x plus 2 equals what? 82. All right? And there's our equation, right? We've got it. So Thomas, to solve this then, what should be my next step? Yep, you got it. Subtract 2 from each side. Great job. Exactly right. I get 5x equals 80. And then final step here, Thomas? Divide by 5. You got it. And that's x equals 16. Okay, so another x equals 16 here. All right, but that's the idea. That's it. Okay, just set them equal. They're vertical angles, so you set them equal. All right, now this is review from earlier, right? But what could we say is the relationship between angle 1 and angle 2 in this picture? Anyone want to not take a guess, but say something here? What can we call the relationship between angle 1 and angle 2? It's one of our previous vocab terms. Eli? Okay, supplementary. We could say supplementary. What's another name we could call for 1 and 2? They are supplementary. What else can we say? It's another previous vocab term we just did. Yeah, Deb? They're also a linear pair, too, right? Exactly right. 1 and 2 are supplementary, but they also are adjacent, right? So they make a straight line. Do we have any other linear pairs in this picture besides 1 and 2? Robert? 4 and 3. Yep. Do we have any more? 3 and 2, and also 4 and 1, or 1 and 4. Exactly right. Good job. Okay, so just because we're talking about vertical angles doesn't mean that other stuff can't show up. So yeah, here we also had linear pairs, and all those are also, since they're linear pairs, they're also supplementary, right? So like, all the stuff. All right, mind blown. All right. Last thing, here it is. All right, we're gonna look at 4 more relationships, but they're all gonna result from the same thing. Okay, so if we have 2 lines. And this is we're almost there, guys. I know. Okay, 2 lines crossed by another line, like this. Okay, 2 lines crossed by another line, and this is it. This is called a transversal. Transversal. Okay, so transversal, right? Again, it's a line that crosses 2 or more lines. Okay, that word, that trans, is a prefix. It means to kind of like go across, right? Okay, so when you transport something, transport literally means to, port means carry, and then go across is trans. You're like going across, you're carrying something across something, okay? Carrying something across a distance. When you transport something, you're carrying across a distance. So transversal is to mean kind of to go across these 2 lines, okay? Transversal, crosses 2 or more lines. All right, now, as a result of having these 2 lines then crossed by this transversal, we create a bunch of angles here. We create angle 1, 2, 3, and 4 up here, but then we also create angle 5, angle 6, angle 7, and angle 8 down here. So we create, 8 angles. This is a lot of angles, I know. It's a bit much. All right. So some other things I want to mention here. We create, this is the interior, because it's between the 2 lines here, okay? So that's the interior. All right, and then we also have the exterior, and that's outside the 2 parallel lines here. Or not parallel lines, the 2 lines here. So that's exterior, and this is also exterior up here. Okay. So the interior is between the 2 lines, the exterior is on the outside of those 2 lines. All right. So then here are the relationships that we're going to talk about. Like I said, we're going to talk about, there's 4 more here, and that's it. We're not going to do any math with these, we're just going to identify them. All right, so 1 pair of angles, or 1 relationship that we're going to see, that we see here, is something called corresponding. Okay? The key word for corresponding is they're kind of like, you can consider them to be kind of like matching. I'll put the word matching in parentheses. We never call them matching angles, but I'm going to put the word matching in there because that's basically what you're looking for here. Alright? And again, once I kind of show you, I think it'll make more sense. I'm not going to like write a definition out. I think it'll just be helpful to just see some examples. Alright, so for example, oh wait, sorry, I think I'm getting ahead of myself. Give you guys some time to write that down. Okay? I know it's a lot. You guys are doing a good job here. It's a lot of vocab. Okay. Alright, so corresponding angles, matching angles. So what I mean by that is, if you look up here, we have a kind of a cluster of 4 angles, right? 1, 2, 3, 4. And then down here, we also have a cluster of 4 angles, 5, 6, 7, 8. Angle 1, in this cluster of angles, what does that correspond or match to down here? Anybody? Yeah, angle 5. So guess what? Angle 1 and angle 5 are corresponding angles. Angle 1 and angle 5 are corresponding angles. Okay? They're matching. They match in the same position. Is that the only pair of corresponding angles that we have here? Eli, what's another pair? Oh, sorry, you had something to say.
Angle 1 is, isn't it also, angle 3 and 7?
Yes, so angle 3 and angle 7 would also be corresponding. All right, anything else? Angle 2 and 6, and then angle 4 and 8. Very good, exactly right. So angle 2 and angle 6, angle 4 and angle 8. And yeah, 3 and 7, yep. So it's only 4 pairs. Those are it, though. Okay, is that what you're saying now?
No, I was gonna say it's pretty much like all of them are the same.
Yep, exactly right. 1 and 5, 2 and 6, 4 and 8, and 3 and 7. And then, yeah, we'll see an additional relationship that shows up. Once we say that these two lines are parallel, you'll see an additional relationship. And, yeah, they're going to be equal in measure, too. Yep. All right, so next one. Alternate interior. Okay, alternate interior angles. All right, alternate interior angles. So since we're talking about alternate interior angles, that means we're only dealing with the angles that are on the interior here. So that's 2, 3, 8, and 5. We're going to ignore 1, 4, and 7, and 6 right now because those are exterior angles. They're on the outside. So we're only going to focus on 2, 3, 5, and 8. Alternate interior means they're on different sides of the transversal. So angle 2 and angle 8. 2 and 8 are alternate interior angles. Okay, they're both in the interior and they're on opposite sides of that transversal. One, we're relating from 2 from up here down to 8. Okay, there's one other pair. What's the other pair of alternate interior? 3 and 5. You guys got it exactly right. Angle 3 and angle 5. That's the other pair. Okay, angle 3 and angle 5 are alternate interior. All right. Oh, sorry. I'm off the screen there. Sorry about that, guys. All right. 2 more angle relationships, and then we'll do a little activity here. Okay. We'll just do check to make sure you got it. Okay. So next one, we have alternate interior. So guess what? We also have alternate exterior. You got it. Okay. It's like mathematicians are not very creative in their naming. We are not very creative, but that's okay. They have lots of meaning. So now instead of looking at, we're not going to look at 2, 3, 5, and 8. We're going to get 1, 4, 6, and 7. Okay? So it's the same kind of idea, though. So in this case, for example, angle 1, what do we want to say that's alternate exterior with? 7. Yeah, exactly right. Angle 1 and angle 7. They're both on the outside, and one's on the right side of the transversal, the other one's on the left side. Okay, angle 1 and angle 7. And then we have one other pair of alternate exterior. Angle 4 and angle 6. You guys got it. Good job. All right, that was the next to last one, and this is the last one then after this one. So questions on any of these so far? These, again, only show up when you have 2 lines crossed by a transversal like this. All right, last one. We'll say co-interior. Also sometimes called same side interior. There's lots of different names for this second one, or consecutive interior, but anyway, we'll say co-interior for this. Okay, so co-interior, co means to share, and again we're talking about interior angles, so we're going to ignore 1, 4, 6, and 7. We're going to focus on 2, 3, 5, and 8, because they're on the interior. Angle 2, co, that means it shares the same side. So angle 2 shares the same side as what interior angle? 5. Yep, so angle 2 and angle 5. You got it. Angle 2 and angle 5. And then angle 3 and angle 8. Okay? And so that is... That's all the angle relationships. That's it, guys. It's just like, 100 different angle relationships I want us to know. So, let's see. pass it down, please. Take one of these and pass it down, please. Okay, so familiarize yourself with your little paper there. You'll see some of the angles that we talked about today, right? All right, so you'll see on the front and the back angles that we talked about today. All right? Yeah, sure. All right, so I'm going to put up a picture right here. Okay. So you can see we have two lines crossed by transversal, and I'm going to have you guys. So we'll do an example here together. That way it's not like kind of crazy here. But we'll start out with okay. So angle 1 and angle. Oh, you can't see that. Hang on, let me zoom out. So there you go. Okay. So angle 1 and angle 7. What kind of angle relationship is that there? 1 and 7. Of the options that are on our card here, all right, which one is it? And if you want, you just so what you can do is you can well, just tell me for now, right now. So yeah, what do you say there, Gabe?
I want to say alternative interior or exterior.
Okay, so let's take a look here. 1 is on the outside, right? It's outside, but 7's on the interior. So we can't say alternate exterior because so Eli? Vertical. Antoinette, what do you say? Vertical as well. Yeah, so these are vertical angles. And so to show that the answer is vertical angles, you would pinch your finger right there next to it and show it up to me like that. Okay? And so I'll kind of go around the room and say yes, 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 no, yes, yes, no, yes, stuff like that. Okay, that's what we're going to do. And so yeah, the answer then is vertical angles. Okay? All right, so we'll try another one here. All right, so 3 and 7. 3 and 7. What are those? 3 and 7. I need to make sure I get it there. Okay. So again, just hold it up once you think you've got it. 3 and 7. Yes. Good, Ray. Yes. Not quite. Yes. Which one are you pinching? The top one?
Yeah.
Okay. So no, not quite. Yes. Antoinette. Good. Dorian. Yes. Good. Yes. 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 Okay. Yes. 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 Not quite, no. Not quite, no. Yes, 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 yes. Yes, yes. Okay, good. So, answer here should be alternate interior, right? Okay. 3 and 7 are both in between the two lines, and they're on alternate sides of the transversal, right? This one's on the left side, that one's on the right side there. All right, let's try another one. All right. 2 and 3. 2 and 3. So this and this angle. Okay, what's their relationship? So go for it. Yes, good, yes, good, good, yes. Yes, 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 yes. Slunkin, yes. Yes, good. EJ, yes, good, yes. Colin, good. Colin, yes, good. All right, yes, good. Two girls in the back there, yes, good. All right, so it should be co-interior here, co-interior, okay, or same side interior. Again, 2 and 3, they share the same side, and they're on the interior, they're in between. All right, let's see here. How about 4 and 6? 4 and 6. Okay, 4 and 6. Let's do, not quite answering that. No, yes, Rob, yes. Good, yes in the back, good, yes, yes, yes. Nope, not any of those. No. Close, not quite. Let's see here. Yes, 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 yes. Good job, Courtney. Yes. Which one? That one? Nope, not quite. It is on the outside, but it's not. One's on the outside, one's on the inside. Yes, yes. Good, Josh. Exactly right. Alex. Yes. Good. 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 Actually, not quite there, Dorian. Actually, sorry. No, not quite. And then yes, Addie. Yes. Okay. All right. Good. So these are what? vertical. 4 and 6 are vertical angles. Vertical angles. Okay, vertical angles. All right, we'll do one more here, and then we'll quit. All right. 5 and 7. So 5 from this cluster, and then 7 from that cluster. Okay, 5 and 7. So yes. Okay, not quite. We don't know that for sure. Yes, Ray. Good job. Yes. Okay. So again, 5 and 7. Still need to see some more. Kwanya, yes. Colin, yes. Good. Not quite there, Gabe. Yes, Eli. Yes, Rob. Yes, Dorian. Yes, that's right. Yes. Good. Exactly right. Alex, yes, that's right. Okay. Close. Yes. Good, Colin. Yes, good. BJ, good. Exactly right. Yeah, so corresponding angles for this last one, okay? All right. No, I'm going to come around and recollect those for my next block class.